In this video, we're going to continue our discussion with goodness of fit tests. So let's take a look at the next example. A statistics teacher claims that, on the average, 20% of her students get an A, 35% get a B, 25% get a C, 10% get a D, and 10% get an F. The grades of a random sample of 100 students were recorded. The following table represents the results. Test the hypothesis that the grades follows the distribution claimed by the teacher. Use the alpha equal to 0.05 level of significance. Okay, first off, we need to know what the expected counts are going to be. So, 20% of 100 is equal to 20. 35% of 100 is equal to 35. 25% of 100 is 25. We've got 10% of 100, that's equal to 10, and the same thing for the F. So, I will put the expected counts below the observed counts now. Okay, now we need to make sure the conditions have been met. So, all expected counts are greater than or equal to 1, and none of the expected counts are less than 5. Okay, conditions have been met. Now let's write out the null and the alternative hypothesis. So I'll do that now. So the grade distribution follows as the statistics teacher claims. That's the null hypothesis. The alternative hypothesis, the grades follow a different distribution. So again, this is going to be chi-squared goodness of fit test. We'll type L1, comma L2. 5 grades minus 1 is 4. And remember, we know that the observed is going to be L1 and the expected is L2. So let's put that in the calculator now. Okay, so we have put the observed as L1 and the expected as L2. So now we do stat, test, and we're going to go to letter D, chi-squared goodness of fit test. Observed is L1, expected is L2, degrees of freedom 5 minus 1, that's 4. Highlight, calculate, hit enter. And P rounded to the value, rounded to 4 decimal places, 0.0137. So let's put that on the paper now. Okay, so the P value is written, and this decimal is clearly less than 5/100, so we're going to reject the null hypothesis. So let's write out the conclusion in the context of this problem now. There seems to be sufficient evidence at the alpha equal to 0.05 level of significance to conclude that the grades follow a different distribution from what the statistics teacher claimed. Okay, let's take a look at the next example. A player in a craps game suspects that one of the dice is loaded. A loaded die is one which all the possibilities are not equally likely. The player has thrown the die and recorded the outcomes below. Can you conclude at the alpha equal to 0.01 level of significance that the die is not fair? Okay, before anything else, we need to write out what the expected counts for this are going to be. Well, in order for us to do that, add up the frequency, and that gives you 60. So, the probability of rolling a 1, 1/6, times 60, that's 10. Probability of rolling a 2 is also 1/6. So every one of these expected counts is going to be 10. Okay. Now I'm going to write out the conditions to use the test now. So all expected counts are greater than or equal to 1, and no expected counts are less than 5. All right, I've already written out the null and the alternative hypotheses earlier, but let's write them out again now. Okay, so the null hypothesis, the probability of rolling a 1 is equal to the probability of rolling a 2, so on and so forth. The alternative hypotheses, at least one of the proportions is different from the others. So again, we'll put this in as chi-squared goodness of fit test. It'll be L1, comma, L2. 6 different numbers minus 1, that's going to be 5. And remember, this will be L1, and the expected will be L2. So let's put this in the calculator now. Okay, so I put the observed values as L1, and the expected counts for L2. So again, go to Stat, go to Tests, it'll be letter D, chi-squared goodness of fit test, observed is L1, expected is going to be L2, degrees of freedom, that's 6 minus 1, that's 5, highlight calculate, hit enter. So to rounding to 4 decimal places, that's 0.0941. Let's put that on the paper now. So that's written out, and we can see at this particular stage that that decimal is not less than 1/100th, so we do not reject the null hypothesis. So let's write out the conclusion with respect to this problem now. There is not sufficient evidence at the alpha equal to 0.01 level of significance to conclude that the die is loaded, aka not fair.